Hello YouTubers and flat earthers and globe earthers, because I see a lot of globe earthers are taking interested in these videos, so that's really good. I'm not saying globe earthers are wrong, I'm not saying flat earthers are wrong or right, I'm just saying things don't add up. And here's a little video just to show this here program I'm using is called Google SketchUp or Trimble SketchUp, and I've drawn in it here a globe earth, right? But I've also drawn I've drawn just beneath this infinite plane. So this green here represents the plane, infinite plane, and the blue is the sky. So that's the ground and the blue is the sky. But underneath it there I've got a scale model of the planet Earth on a true round. So we're going to talk about that. So some points have come up and people are saying that I am tilting the model or I am changing things. I am not doing it correctly. So we're going to take a few look at that. Now here is the program. It's called Google Trimble SketchUp. If I come in here and select this man here and put him on the very top of the earth and look out in a direction, I'm going to pick the green direction if I can get it here. It might take me a bit of time to get it. I'll tell you what I'll do. I'll undo that and I will switch on the axis so I know where I'm at. Okay, so get this tool, click here and look out this green axis and let's see what the model does. Right, so what the model does is this. I don't know if you can see that. It puts the horizon line here between the blue and the green dead in the center of the screen. But the curve of the ball, which would start at the horizon line and curve down to here, there's a mile and a mile 0.5 of a drop. Let's say from here up to here instead. So come up. Okay, there's a line there, see, and you can see it's about 1.3 miles up to the flat plane, right? So you have to say, well, what is that 1.3 miles? So I'm going to come back out again and rerun it this time, and we'll look out the red axis. So make sure I'm on the red axis, so don't make a mistake there. And we get the same thing. Now, what it's saying is if you have a pair of eyeballs and you stuck them on a flat, say the top of a football, a round football, the only thing the camera would pick up on a round football would be this line down here. But if you were to put the camera on a flat table, the camera would pick up this line here. Probably not the best examples, but so let's zoom out and have a look. Now the computer program, Trimble SketchUp, it always every time puts the line in the center when you go in view. So whoever invented this program knew that the green plane and the blue plane always merges in the middle of your view, and that's why the computer runs. So let's click and zoom along and let go, and it puts it back in that same position. So I'm going to zoom out again, switch off the wireframe mode. I've got a line there, I don't know what it is. I need to rub that out, whatever that line is there. Okay, it's just a construction line. So what else can we pick up from this? Okay, I'll tell you what I'm going to do. I'm going to draw a line here, and I'm going to go up this line. I'm going to go up 1 mile. Remember, the model beneath is to scale, so when I switch off my axis and I zoom in, I keep zooming in. Actually, I mustn't have put that line on there. Come up, put in 1 mile. So there's 1 mile up, that little line on the Earth. 1 mile, right? So I'm going to zoom on in. There's 1 mile up. So I'm going to delete that line. And I'm going to put in a mile. I'll put a line in that is 0.1 of a mile. So come up. And that's 0.1, press enter. So there's about 1/10 of a mile, right? If I zoom right in there. Now what I'm going to do is I'm going to go in there on the 1/10 of a mile. I'm going to half that again, start my viewing. If I can click on half of that. This is quite delicate measurements now. Right, I'm halfway on the line and I'm going to view. Let's see, go on the, where is it? If I get the red axis somewhere here, there. Go let go and let's see what happens. Okay. Well, I've gone up there 0.05 of a mile into there, and the camera or the viewing person still sees the horizon level with the view. You see horizon's level right through the center of the screen. So now I'm going to go and go up higher. Let's go here. So we're going to go up, say, 50 miles. Okay. And then we zoom in here. I'll switch on the axis because it'll probably help a wee bit better now. Come up here to this line. Now zoom out and look out here. Now what do you see? 50 miles up, you're looking down. The line is still here, center of your screen, but look where the Earth is down here. Okay, so 50 miles might be quite high. That's because it's 62 miles to the, is it Faraday line or whatever? It's I can't remember the name of the line, but it's where space meets the atmosphere, where we go into outer space. That's according to the Astronomical Institution of Science or something. So 62 miles up to that. So you see, let's go back out and this time switch off the axis here. And this time we are going to put in, we're going to go up, say 10 miles. So we're 10 miles up and now we're viewing out, and what this view that we're viewing out is dead level. So once that line goes red, it's dead level. There you go. That's dead level looking straight out. Watch what happens. There you go again. There's eye level, or roughly eye level. Maybe it's a wee bit beneath or above, but it's always going to be roughly your eye level. And if people want to bicker about what eye level means, they can do, but we all know in general, if you look out, the horizon's roughly at your eye level. But here, quite clearly, you see, if I went up 10 miles and looked out straight on a ball, and this is to scale, this is the ball that you would see, well beneath eye level. But if it's flat plane, it's roughly eye level. So those people who are trying to strain at that and saying eye level is not eye level, it's beneath eye level. And another thing, what they're doing is they're cheating you. You're saying what they're saying is you use something to look through first before you look at the horizon. What they're saying is look at something level or put a level up, then you have to bend down to see the level. Well, that's stupid. That's putting an intermediate object between you and the sight. Everybody knows if they walk outside and look around you, you will see the horizon line right around you, roughly at eye level. Could be beneath, could be slightly above, but it's roughly there. This model that you're seeing if the higher you go up, look at the distance there between a horizontal plane and a curved ball earth. You do notice that you are seeing a curve. There's a curve there on a, see, on a ball earth. But I want to show you something first. Let me just do this. Click and go back out again. Looking straight out. To see that curve is now impossible because it's so slight over this length. You can see it, just that slight little bend there. But obviously it's not at eye level. There's eye level up here. It's miles beneath, and that's 10 miles up. So all the videos I've seen where people have gone up 10 miles or more, the horizon is always eye level, never way down at this level. And this is all to scale. This model is all to scale. And you can check this out and do it yourself in a program. So Trimble SketchUp has it right. They have two infinite planes, and when you look, you'll always get, when you look straight, that's what I'm doing with this little, let me show you. When I use this little icon here, put my mouse over it, it's called Position Camera, View with a specific location, eye height, and direction. Now the direction you've seen me do that, let's zoom back in here. Here's the direction. I am pointing out, let's get a direction here. I want to get the red direction. This red direction. I'm pointing out tangent and let go. There you go. So I clicked it on the wrong thing. But you can see the drop there. That's 10 miles. Remember we were up 50, it was even bigger. So that proves to you. I'll just do it again in case somebody thought I was cheating there. Line, let go. And you see it's getting the same result. I'll do it again just in case. Okay, red line. There we go, let go. Same result. So you see, if you go up 10 miles, the horizon line, the earth line would drop down, what you would see. And quite clearly on an infinite plane, it's going to be roughly your eye level. So that's your proof for you. Maybe I should address this too, because if you go outside and look around you, you go out and stand outside and look around you, like on this model here, if you go out and look around, you are seeing that line there on the infinite plane. You're not seeing this line here of the earth, because that looks down the ways. You can't get an horizon line at your eye level on a ball. Remember, you're standing here and we're going to look out this way this time. And you see the way the earth curves away from you. So the horizon line can never be at eye level. It's always going to be beneath your eye level. Even right back up into here, even up to 15 miles. So these people are saying these things. Okay, maybe you're genuinely wanting to know. Maybe the globe earthers are wanting to know. But I'm just trying to show you that these models here make more sense for an infinite plane than a curved earth. But I did want to say something else there. I wanted to show you. Okay, here's what I'm going to show you. This is what some of the guys are saying to me on the comments on the other videos. So let's start with a new model. If you have a model, and if you understand geometry at all, let's make this a nice smooth model. If I zoom in on this and I draw a tangent to this, right, that's tangent to the earth. That's your line of sight, dead straight, looking straight out. Nowhere can you start at a point of sight, draw a line, and bump into land again. But as we see, when we look out, we see land above our feet. It's almost at eye level, the land in front of you. This proves to you that you're on a plane. If you don't get this, you need to meditate upon it and dwell on it. And if you think I'm wrong about this, then demonstrate it. I'm showing you computer-aided models here. But just the law of geometry alone tells you that a line tangent to a circle only ever touches that circle once. So this is your line of vision. It'll only touch the top of the circle. If I keep on going and then I see land at my eye level horizon, that means I'm touching the land again with that line of sight. It doesn't add up. So the only point that land would touch, or that line there, that line of sight would touch, is where your feet are standing. And if it's on a through ball, it will never touch land again. It would never touch, you would never see land again. As that line shows, it doesn't touch the circle or the ball again. I don't know if you can see what I'm saying there, but you need to dwell on that. So, what else can we see from here? I think I'll leave it at that. You can do these tests yourself, and I think Trimble has done a good job showing the infinite plane in their model, and that does prove why the horizon is at eye level, or approximately at eye level, for those of you who are are critiquing this work. It's not up to me to prove a model to you. It's up to you to go outside and look around you and observe the perspective. The perspective clearly shows the sky coming down and the ground going up to meet the horizon. That is impossible in a ball Earth. Thanks for watching.